In Chapter 8, Section 1, we begin our discussion about inverse variation. Inverse variation means as one item goes up, another item goes down. They are inversely related one to another. I'm going to share with you this problem that I found online when we get back to class. So go ahead and flip. I'm going to teach you how to find inverse variation versus indirect variation versus direct variation using a table. Okay, so we're going to look at how to use a table to figure out if it's direct or if it's indirect. Alright, let's put indirect, or let's change this word to inverse. Direct or inverse? Problem 1. Is the relationship between the variables directly related, or is it an inverse variation, or is it neither? Write a function model. Now anytime it says write a function model, all it wants from you is an equation, okay? For the direct or the inverse variation. Take a look at part A. Look at all the x's versus all the y's. Something you should notice that the x's, as you go down, the x's are going up and the y's are going down. So we're going to check out and see if this is an inverse variation problem. Now here's how you test. Ready? In order to test, you're going to test for inverse variation by doing this. You're going to do x times y. The next thing you're going to test is direct variation. And in order to do direct variation, you're going to do y divide by x. And it's pretty much that simple. Alright, let's check out part A. I'm going to try inverse variation first. Now remember, to test inverse variation, you do x times y. So I'll do 2 times 15, and I get 30. Now I'm going to do 4 times 7.5, and again, I get 30. You have to test the whole way through. 10 times 3, I get 30. And 15 times 2, I get 30. These are all the same. This is an inverse variation. It's not necessary, but you can see that direct variation won't work. If you test direct variation, you do y divided by x. So in this case, I would do 15 divided by 2, and I would get 7.5. And then I would do the y, 7.5 divided by 4, and I get 1.875. Those are not the same, so it's not direct. Do you see how these are all 30? That is what you call your constant. Okay, that is going to be the value of k. Now what I want to go is I want to go back up here to inverse variation. Inverse variation is written y equals k over x, k being the constant of varying. And the direct would be y equals k times x, where k would also be the constant of variation. Because this is an inverse problem, I'm going to write y equals k over x, and now I'm just going to plug in the k that I found, which is 30. I'm going to make that say y equals 30 over x. That means if you take 30 and you divide by x, you will get all of the y values. Let's try part B. I'm going to notice that as the x values on this one go up, the y values go down. I'm going to try inverse, and I'm going to try direct as well. Inverse variation, let's do this test. Inverse variation, remember, is x times y. So I'm going to start with 2 times 10 equals 20. And then I'm going to go to 4 times 8 equals 32. Can you see how these are not the same? This is not inverse. Those values would have to be the same as each other to be a perfect inverse function. Let's try direct variation. Remember, to try direct variation, you take y and you divide by x. So in this case, I would do 10 divided by 2 and I'd get 5. And I'd do 8 divided by 4 and I'd get 2. Can you see how those are not the same? This is also not a direct function. So this one, we're just going to put neither. You can't make an equation out of this. Moving on, I have 3 more for you to try. Let's do A. I'm going to take a quick look. I'm going to notice x goes up and y goes up. When that happens, I'm going to try direct variation. When they're both going up or they're both going down. If I'm wrong, I simply move to inverse. I'm going to test for direct variation. And to test for direct variation, I do y divided by x. So I'll do 8 divided by 0.2. On your calculator, 8 divided by 0.2 is 40. All right, let's try 20 divided by 0.5. 20 divided by 0.5 in your calculator is also 40. Keep moving down. 40 divided by 1.0 is 40. And 60 divided by 1.5 is also 40. You see how all of these match? That means that this one is a direct variation. Because y divides by x. This is the k value, 40. So direct variation is y equals kx. And in this example, k is 40. So I write y equals 40x. In part B, I'm going to notice that as the x's go up, the y's go down. So I'm going to start by testing inverse. Again, if you don't know which one to start, just test both of them. But when they're opposites, I test for inverse. Alright, well, testing for inverse, I do x times y. So I'll do 0.2 times 40. 0.2 times 40 is 8. Now do 0.5 times 16 is 8. 1 times 8 is 8. 2 times 4 is 8. Can you see how all of these are the same? That is the value of k. Inverse is this one. Inverse variation is what I'm writing. And for inverse variation, y equals k over x. In this particular problem, k is 8. So y equals 8 over x. In part C, I can test both of them because I do notice as x goes up, y goes down, so I can try inverse first. When they're opposites, I'm going to try inverse. Okay, so I'm going to do x times y for inverse variation. So 0.5 times 40 is 20. All right. 1.2 times 12 is, well, let's get our calculators and figure it out. And this is all I'm doing, guys. I'm just multiplying for inverse. 1.2, here you go. You can see what I'm doing. 1.2 times 12 is 14.4. You see how these don't match? It's not inverse. All right, let's try direct variation. Let's do y divided by x. 40 divided by 0.5. 40 divided by 0.5 is 80. Well, that doesn't work. Well, let's try the next one. 12 divided by 1.2. Unless we get 80, we're not right. So 12 divided by 1.2, I get 10. So this one is neither. Okay? There's no constant. Moving on to problem 2. Problem 2 is determining an inverse variation equation. Now what you're going to have to notice is the fact that it says suppose x and y vary inversely. Right here, get my highlighter. That little sentence is really important to you. Suppose that they vary inversely. Because that says that, we can right away write y equals k over x, because it says so in the problem. Now it says x is 4 when y is 12. So the next step we're going to do is we're going to plug those numbers in. 12 equals k over 4. I replaced y and I replaced x. Next step, if I can number these, step 1, step 2, step 3, I'm going to multiply by 4 on both sides. So I get 48 equals the letter k. Now it says what function models the inverse variation? What that means is, what is the equation? Well, I find k, okay, and I find k by plugging things in. And then the last step is I make my equation. My equation is y equals 48 over x. And that's it for the equation. Part B, it says, what does the graph look like? Well, in order to do the graph, okay, we're going to do this graph, then we'll move to a new video. In order to do the graph, you're going to have to make kind of a big XY chart so you actually know what it looks like. All right? Because y equals 48 over x, you should make a note that x cannot equal 0. Why can x not be 0? Because you cannot divide by 0. Okay? So when I make this XY chart, I know you're not going to like this. I'm going to make 2 because my paper is not quite big enough for the one that I need. I like to pick numbers that work. So I'm going to pick factors of 48. So these work, okay? I'm going to pick factors of 48 so they work. Alright, well the first one I'm going to go big to small. I'm going to do 48, okay? 48, and then you plug it in. You do 48 divided by 48 equals 1. Next, we pick 24. Why did I pick 24? Because 48 divided by 24 is 2. Move down. 23, 22, 20. Keep going all the way until you get a nice next answer. What goes into 48? 16. 48 divided by 16 is 3. Keep going down. The next number that goes into 48 is 12. 48 divided by 12 is 4. The next number that goes into 48 is 8. 48 divided by 8 is 6. The next number is 6. 48 divided by 6 is 8. Next number is 4. 48 divided by 4 is 12. Next number, 2. 48 divided by 2, 24. Last number, 1. 48 divided by 1 is 48. These are all your positives. What you need to do on the next section here is you need to make them negatives. Now this is going to be easier, okay, because you just plug in things like negative 48. You just take this and you change the signs. So negative 48, negative 24, negative 16, negative 12, negative 8, negative 6, negative 4, negative 2, negative 1. Okay? And then you do the same things over here. You just negative 1, negative 2, negative 3, negative 4, negative 6, negative 8, negative 12. I could have done negative 3. I didn't, but I'll get a nice picture anyway. Negative 24, negative 48. The last thing we need to do, and I know this takes a while, that's why we're only going to do a couple of them, is plot your points. So I'm going to skip by 5s on both of my axes. Okay, I'm going to skip by 5s on both of the axes. Once you plot, let's go ahead and take some time. Pause the video if you need to. Plot your points. I'm going to do so silently. Again, plot your points, pause the video, and check if yours match mine. Right now all I'm doing is I'm plotting my positives. You should notice that your graph is going to almost look like a funny exponential equation. It's not, but notice how it approaches both of the axes, but it never touches them. The other side is going to be the same. I'll start the next video with what the answer looks like. Now I'm going to have to put all of them down here now, okay? So it's going to be the exact opposite. And that's how all inverse problems look.